In this video, we're going to make a temporary speed boost power up. So if I touch it and move really fast for a couple seconds and then it stops, we're going to implement our speed boost using interfaces. So it's going to be a bit more modular and reusable. And then we'll look at how we can use our interfaces to add speed boost to other objects in our scene without specifically testing every single object. So we can have one speed boost and then our interface will speed up different objects in different ways, which will let us really see the power of interfaces as we build our mechanic. So before we start building some mechanics, let me show you why we're going to take the approach with interfaces. Early on in your tutorials, you're probably going to come across something like this, where you might have a speed boost and you need to do something to, let's say, the player pawn. And what you'll commonly see is the speed boost casting to player pawn. So it's trying to test if this object is a specific kind of class and then running a function on it. Now, this is fine early on, but it's not very expandable, and I'll show you why. Imagine a scenario where we have our speed boost and we have a player pawn who can speed up, but maybe we have an enemy who can also use a speed boost. Maybe we have a projectile that can get faster if it goes through a speed magic field or whatever else. We could have lots of different things that might need to use the speed boost. And furthermore, maybe they speed up in different ways. Like maybe our player pawn uses and our enemy uses set actor location, our projectiles use projectile movement, and so forth. And the problem here is we can't cast to every single possible scenario. We don't know all of the different actors that we're going to end up making. So the better way to do this is with an interface, where we're going to create an interface blueprint where we can define a function. So in this case, speed up from the speed boost, and our speed boost will just test and see if this actor has the interface to let it speed up. So now our speed boost is just communicating through the interface, and then each of the different actors can implement their own speed up in different ways. So our player pawn can speed up however our player's moving, our enemy can speed up however our enemy's moving. We can have different sound effects, we can have different particles, and so forth. This is the better way to work because it's infinitely expandable. Now the downside is that we have to type in all the code for each different implementation and we don't get a lot of base behavior. There's other ways to solve that. There's definitely pros and cons to that approach too. But for now, we're just going to look at a simple way that we can use interfaces to create modular behavior for our speed power up. Our first step is to create the interface. So open up our content browser. I'm going to create a new folder and call this interfaces. Inside of here, we're going to right click, go to blueprint interface. That's the one we want. The naming convention for a blueprint interface is BPI underscore and then the name of the thing. Traditionally, it's good practice to add ABLE to the end of your name. So it is speed boostable or damageable or so forth. It doesn't always work out that way, but if it can be named that thing, it's usually a good starting point unless you want to get more specific. So we'll call this speed boostable. Sounds kind of weird, but to make this concept stick, I want to try to stick to the basics. Save, open it up, and now we need to create the signature for the function that we want to call through the interface. In other words, whatever function we make, every single actor that tries to use this interface needs to implement this function. So let's call this speed boost. So every other actor will need a function named speed boost once we implement this. And furthermore, we might think of what information do we want to pass through so that the other actors can do their job. I might want to know, for example, how fast, right? We'll call that a multiplier. So I'm going to come down here to inputs. I'm going to add a new input and we're going to call this multiplier. You might also think of this as an amount, but basically, what do I want to multiply the speed by in order to move faster? This will be a type of float. And we can actually define a default value. We'll say default 1.5. I think that's a decent default. I'll save. Now, because this is a temporary speed boost, another thing that I might want to pass through is a duration, right? How long do we want to speed boost? So I'll call this duration. It is also a type of float, and I think a good default, 2 seconds, 3 seconds. Either of those would be fine. Let's compile, save. So now we have defined the signature of the function that other actors need to implement. So what we're going to do is we're going to look at how we can implement this interface on our player. To implement this interface, we're going to open up our player pawn, just whatever the thing is that we want to speed boost. We're going to come to the very top. It's called class settings. Click on that. And over here on the right, one of the things you're going to see is a drop down for interfaces. Implemented interfaces, we don't have any, so we're going to add, we'll type in BPI underscore because we named it correctly, and we're going to select our speed boostable, compile, save, And what this is going to do, if you look over on the left, the interfaces that this ball pawn has implemented is SpeedBoost. Now we're not actually using it yet. So if we come over here and we double click, we can define our SpeedBoost however we need to on our ball pawn. But because we have implemented our interface on our ball pawn, now we can call the SpeedBoost generically through the interface rather than casting into this object. So just to prove that this works, we're just going to do a little print string, SpeedBoost, and then we're going to set up our SpeedBoost pickup, and then we're going to create our SpeedBoost next. And as long as we get this, then we know that we're doing it right. So we'll compile, save. So let's go ahead and create our SpeedBoost Powerup. I'm going to come down here to pickups. We'll right click, blueprint, actor, and we'll call this BP underscore SpeedBoost Powerup. We'll control S to save. Let's open it up and give it a visual so that when we place it in our scene, we can actually see it. I'm gonna keep things real simple and just use some basic shapes and template kind of things, just so we can test the functionality. So I have my sphere. One thing I'm gonna do is I'm gonna make it a little bit smaller. So 0.5, 0.5, 0.5. I'm also going to change the material to something more interesting. It's usually best to use a material instance whenever possible. You could also make your own. So I found one material instance that's just built in the editor. Another thing I want to do is I want to disable the collisions on this because we're going to make a separate box collision. So on my sphere mesh, I'm going to come down to collision, turn that to no collision. All right. Compile, save. Now we're going to add our box collision. So box collision. I'm also going to drag my box collision up and attach it to our default scene root. So it is surrounding the sphere after we resized it. This is pretty good. Now, another little trick I want to show you is I'm going to add something called a interp to movement. It's a little actor component right here. And what this is going to do is I can define a few points in local space and this object will move between those points. It's really quick to set up. And the reason we want to do this is once we put it in our scene, we want it to kind of like bob around and move a little bit. It's usually best to have some kind of movement on pickups and interactable things in our level. So interp to movement, I'm going to come over here. The duration is the total amount of time that it takes to move through all the different points. The control points are the points in which we want to move. So I'm going to add a couple, I think 4. Basically, I want a starting point. I want a destination will go up. I want a destination to go down. And then our final destination will return back to our original position. So we're starting at 0, 0, 0. We'll keep that. Our index 1, so our second point, we're going to move up. And I think 15, just a little bit. On our index 2, we're going to move down, so negative 15. And our final one is our original position, so 0. All right, and then the last thing we need to do is tell it to loop. So our behavior type right here, I'm going to do loop reset, meaning that once it gets back to the final point, it's just going to go back to the beginning and do it all again. So once I'm done with this, it should go up, down, and back to the middle. Compile, save, and let's just make sure that this works. I'm going to put it in my scene right here. SpeedBoost Powerup. Okay, if we watch it, it's kind of moving up and down. It has no collision. Okay, perfect. All right, next we have to add the overlap for our SpeedBoost Powerup. So let's open that. Now we already added our box collision over here. So this should be review at this point. I'm going to select my box collision, do begin overlap. I would normally test if it's the player, but I don't want to test if it's the player. I want to test if it's using the interface. So there's a node for that. If you drag off of other actor and you type does implement interface, and this will look on the actor and see if it implements the interface that we attached earlier in our class settings. And if it does, then it'll return a condition. So anything that we apply this interface to should return true. So we'll do our branch. So if it has the interface, no matter what it is, player, enemy, projectile, whatever, and we need to choose the interface that we want to test for. So mine was BPI underscore speed boostable. So if it has a speed boostable interface and we implemented it on that actor, then the next thing we want to do is I'm going to drag off the other actor. And because it implements the interface, I can call the speed boost. And you see this one with message in parentheses. That means that we're calling the interface version of the speed boost. So make sure you do that one. You'll see a little letter, an open letter up there. That means that we're calling it through the interface so that it will then run on the ball pawn that implements it. So it'll go through here. Compile, save. Now the other thing is, since we set up the parameters early, we wanted to pass through a multiplier and a duration. We have to define that. You see that we have our defaults right here, which we could use, but it might be a good idea to let the designer decide what the multiplier and duration should be. They could change it in here, but I think I'm going to set that up as a variable in case I want to do more stuff later. So I'm going to make a multiplier, make that a float. plug that in, plug it in, pull that out. We're also going to make a duration. Make sure it's a float, drag it in, plug it in. And the other important thing is make sure that you have the default value set. So I'm going to compile, save. And on my multiplier, I think 1.5 was good. On my duration, I think 2 seconds was good. Compile, save. And we should be good to test it. So what's going to happen is when my player passes through my box collision right here, this SpeedBoostPowerup is going to look at that other actor, which in this case will be the player, and it's going to look and see if we've implemented the SpeedBoostable interface on that actor, which we did earlier, right? We implemented it and we pulled off and did a SpeedBoost print string. So if it does implement the interface, then we want to call SpeedBoost on that object using the interface. And it'll pass in some information which we're not really using yet, but it'll pass through and we should see SpeedBoost. So let's compile, save, and make sure that that all works. Minimize, hit play. SpeedBoost, perfect. Okay, one last little note here. If you wanted to destroy the object, like you wanted to pick it up and consume it, you could. You would just drag off and say destroy actor, but I don't really want to do it in this case. Just if you have that kind of power up, you could do it right there if you want. All right, now let's actually speed up the ball pawn. Now the way that I have this set up is I've been defining the max speed using a max angular velocity variable. I'm saving off the initial value that I want for that over here. So in your case, if you have a different kind of player controller, you would just need to make sure that you have the initial value that you're starting at as a variable somewhere. And what I'm really trying to do here is just increase the speed. So however your pawn needs to increase the speed, you would do it that way. So the way that I'm going to do it and the way that it works on my character controller is I'm going to drag off the multiplier, use this to multiply by my max angular velocity. So I'll get that. Plug it in. So this will pass in like 1.5, for example, and 1.5 times my whatever my speed is will give me a higher amount. I'm going to take that and I'm going to set it wherever it needs inside of the pawn to make it work. For me, this is through the mesh since I'm rolling through physics. So I'm going to drag off my mesh, set physics, max angular velocity in radians. So this is just dependent on the kind of pawn that you're using. I'm going to drag that out over here. I'm going to have to reposition a lot of this stuff. I'm going to apply the new max angular velocity. So this is my new speed, connect it in. So leave a little comment here. This is essentially just speed up. Let's reorganize this a little. So once I do this, the next thing I want to do is I want to wait for a little bit of time. Now, here's the thing. If I were to just do a standard delay, what if I pass through it multiple times? Remember, I'm not destroying this actor. In this case, I want to delay, but if I pass through it again, I want to re-trigger my delay and start my delay over at the starting point and then count down. And then if I pass through again, restart it again. So in this case, I'm going to use something called a re-triggerable delay. So this way it'll restart if I get the speed boost again before my current one ended. And my duration is how long we want to wait. So I'm going to just plug that in. Now this is kind of messy, so I'm going to use something called a reroute node. If you double click on the line and I'll just drag it down like that. Perfect. Conceptually, I'm waiting, so I'm just going to add this here. This is kind of unnecessary, but since we're learning, I'll leave a few extra comments. And then the last thing we want to do, once we have waited the duration, we want to return to the original speed. Now, in some cases, you may need to save the initial speed value that you want to return to, because if you change it over here, you've already recalculated it and you don't know what to return to. Now, you can undo that calculation and do it in reverse if you want, but I usually like to save the initial value just in case. So for me, I didn't really change my value. I just calculated it and plugged it in, but you may need to. We will look at an example of that later on. I'm just going to copy this whole node over here. So copy, paste. However you set the speed, you're going to set it again just at the original value. So move that over there. I'm going to copy paste my max angular velocity, plug that in. However you need to return the speed, that's what you should do. And I'm going to change my comment to reset speed. And I think that should do it. Let's test it out and make sure that it's functional. Compile, save, hit play. Okay, so you can probably see 1.5 isn't super obvious, but it was speeding up and then slowing down to the original speed after our speed up. So the next thing I want to do is make this a little bit more obvious and do a sound effect. It's always good practice to trigger a sound effect whenever you're doing some basic mechanics. It's good for feedback, and then you can always replace them later. I'm not going to spend a lot of time on this, but let's just get something working. I'm on chip tone. So I clicked one up, and then I'm just going to mess around with this a little bit until I get something I like. All right, so that's good. I'm gonna hit save as wave, come over here. I'm going to rename it speed up sound, and you can import this into Unreal. I'm just gonna drag and drop. Again, it's placeholder kind of. Drag it in. Sometimes that'll close, just open it back up. I'm gonna select my wave, create queue, enter, and then my queue is just gonna let me add some variations. So I'm gonna open that up, drag off, do modulator. So I'm gonna add the pitch randomization here. And we will do, I think, 0.98, 1.02. It's fine, just very subtle. You can test it by hitting play. That's fine. So now I want to play this whenever we pick it up. So I'm going to go to our power up, our speed boost, open that up. And at the point where we speed boost, we want to play the same sound effect. I don't want to do that same play sound effect on each different thing that implements it. So I'm going to do it from the speed boost power up. So after we speed boost, I'm going to play sound and then look for play sound at location or play sound 2D, just depending. I'm going to play it at location, but you could do it in 2D. It'd be fine, especially for a single player game. I'm going to get actor location. Now, because they're touching this, it's fine to just get this actor's location, but you could also get the other actor's location and get that and plug it in. But this one's fine. The sound I want to play is the one that I just set up, and that's going to be my speed up sound cue. So that I get my variation, right? Compile, save. So we should hear that play. Let's test it. Okay, great. I'm actually going to move this over here a little bit. That way I can get a little bit of movement before I touch it. That way the speed up is a little bit more obvious. Okay, there we go. Another thing is, because we made this a variable, I think I do want to turn that up just for testing to make it more clear. Okay, the next thing I want to do is a simple particle burst. It's usually good to have some kind of effects anytime something important happens. And so we can set this up pretty quickly. Under particles, I already have one made, but I'll make another one real quick for you. FX, Niagara system, new system from selected, that's fine. We're going to do the generic burst. Omnidirectional burst is what it's called. Hit plus, finish, call this PS_speed burst. Open this up. I'm going to keep all the defaults, except I am going to change the color, something blue, better. And that's pretty much it. I mean, you can always do other tutorials to customize a better particle effect. I'm just doing this for testing for now. So once we have that set up, we actually need to spawn it in our scene. So we'll go to our pickups, speed boost, and let's just spawn the particle. Drag off, spawn system at location is what we want. And we give it the PS_speed burst that we made. The location, again, I'm going to use this actor's location, so the SpeedBoostPowerup location, but you could also spawn it from the other actor if you want. So I'm going to right click and get actor location. This is getting the actor location of this actor. Plug it in. Okay, auto destroy, auto activate, all that stuff is good. Just make sure you have the correct system set in the template. Compile, save, and we should hear a sound effect and see our burst. Let's try it out. All right, so it's simple, but it's enough to give a little bit of game feel. And again, you can do other tutorials to get better sounds, get better VFX. But the important part is we have something represented there and the gameplay is clear. Now, another thing I want to show you is it's usually good to have a visual associated with an object state if we are changing it, especially for a temporary amount of time. And one way we can do this is a looping particle effect on our player. So in this case, it's on our ball pond. And all I'm going to do here is I'm going to create a very simple generic looping particle effect that will turn on during our speed boost and turn off once it's done. So the first thing we need to do is we need to create our looping particle effect. Come over to particles. I'm going to use one of the templates. It's going to look very generic, but you can always find a better tutorial for doing fancy particles in Niagara. Choose Niagara system, new system from selected emitters. I'm going to scroll down to fountain, hit plus, hit finish, name it PS_player speed particles, Control S to save. Open that up. Now this is spraying the particles upwards. I don't really want to do that. I just want to have them come out from the middle of my character. Add velocity where it says in cone, like once you have this block selected. And I'm going to change from point. So now they should be coming from the middle. And this is going to be coming from the middle of the ball. Let's change the color to make it look a little bit more like our speed boost power up. Make it this light blue. Hit OK. One more thing. I think the spawn rate, I'm going to just spawn more, so 200 instead of 90. compile, save. And I think that's all we really need for testing. Once you have this, the option that I'm going to choose is to have a particle system component on the player for our speed boost that I will just activate and deactivate. There's pros and cons to this. Like if we add too many of these, then, it could get kind of unwieldy and maybe we put that in a component or some other thing. We could spawn it at runtime. There's all different ways to do this. But for now, I'm just going to use this from a component. I'm going to add, looking for Niagara particle system component, call this SpeedBoost PS for particle system. And we want to choose the Niagara system asset over here that we just created. So our player speed particles, not the burst, the looping one. And then right here where it says auto activate, we're going to disable this because I don't want the speed boost particles to play at the beginning. I want to default to off, then I'll turn them on and then turn them back off. So let's do this here. I'm going to select some things, move this over here. I have my particle component, so I'm going to drag this component reference over here. I'm going to drag off and type activate. So now we're turning it on at the moment that we speed up. Pull this up here. Okay, we're going to activate that particle system. We're going to wait, and then we're going to deactivate. So I'm going to pull it over again, pull off, and say deactivate. Now, the other advantage of this versus just spawning, despawning, and then make sure you connect that, is that our particle system can actually die down naturally, how we set it in the particle, rather than suddenly destroying it. This will look a little bit nicer. So compile, save. We are setting our speed, activating our particles that we already defined over here. We are waiting, resetting our speed, and deactivating our particles. Compile, save. Let's test it out. Play. Deactivate. Okay, cool. And as you can see, it's a pretty simple looped particle. Again, there's other tutorials that can do a much deeper dive than I could do right now when I'm trying to show you this other thing. But what's important is that it is working and our system is set up. So we have our speed boost working and we have been using interfaces, but we haven't really seen why the interface is important. Like, why do we even care? We can just cast to the player upon. Well, imagine a scenario. Let me duplicate my speed boost over here. So I have this very simple moving projectile. This could be an enemy. It could be anything you want, but it is something that I want to speed boost once it passes through the power up. We're going to move that a little bit closer. That would take way too long to test. So it's going to move slowly. It's going to pass through the power up and then it's going to move quickly. Well, it would if we set it up. Right now it's not because we didn't implement the speed boost power up. But I have built a system in which now any actor that I want to be able to use this power up, I can implement the speed boostable interface on that thing and then define it its own special way. We've done this for the player. Let's review this whole thing by implementing the interface on another object and seeing that we can get different behavior by using interfaces. So let me show you the setup and the way this is built. I don't want to build this from scratch because it would just make the tutorial take longer. All I have is a simple projectile blueprint that I made. I'm not even using the projectile component. I'm just moving it over time inside of event tick. Again, better ways to do it. I'm just testing and showing a concept. But the important thing is we are moving in a forward direction. We have a move speed that is driving how quickly it moves. That's really all we care about because when we implement our interface, we just want to change the move speed, wait, and then reset it. So that's what we're going to do. So let's talk through it first. What we're going to do is we're going to take our blueprint interface that we defined. We are going to implement it on the actor that we want. And then we just need to define what happens when that speed boost function gets called. Because the speed boost is calling through the interface on any actor that's implementing it. So we should not need to touch the speed boost power up. We only need to implement it on this object and change the behavior here, which is good. We don't need to touch the original object. That's another very big advantage of interfaces. So let's open it up. First step is we're going to apply the interface. Let's find whatever your object is. Mine is a simple projectile. Again, you could rebuild this if you want, but this is just for testing. You will want to do this on any object you want this to apply to. So I'm going to go to the class settings on the other object. I'm going to go to implemented interfaces, BPI underscore speed boostable. Essentially, we're saying this actor is now speed boostable as long as it implements the speed boost function. Let's double click that. I guess in this case, it's an event, either way. So we have our event speed boost, and now we need to speed it up, wait, and reset it. Now I want to show you this specific example because in this case, my move speed is directly tied to my movement. So sometimes you may need to save the initial move speed value so that you can return to it later. So you can typically do this inside of begin play. So I'm going to do that. So if you have this kind of setup, I'm going to create a new variable called initial move speed. So the starting value of this thing, I'm going to make it the same type as whatever I'm trying to store this in this case, the move speed. I'm going to set my initial move speed to be the same value as my move speed right in start. So we're just making an extra little variable container that we are storing the value of move speed so that we can return to it. That way, if we change move speed, this one didn't change. This initial one is our original one. We can just return back to it. We can reassign move speed to that. Hopefully that makes sense. So we're going to go down to event speed boost right here. First, we need to speed up. So we're going to multiply. So drag off my multiplier. Say multiply our move speed, get move speed by our multiplier. Okay, and the result of that, we are going to set the move speed, right? Wherever your object needs to set its speed, again, if you're using like character movement component or whatever, you just need to set the actual speed here. Then we're going to wait. So retriggerable delay. We'll have this little comment, speed up, wait. And we're going to drag in our duration for the amount that we wait. Again, you can clean this up by using little reroute nodes. That's fine. And then we need to return. Now, because we have been changing our move speed, we are going to use our initial move speed to return to. And you could also like divide it to undo it if you want. But I like to do it this way just so that I have a safe return point if I really need it. So we're going to drag in our move speed, say set, or you can copy paste the node over here. Once we have waited, we are going to set the move speed back to our initial move speed. Just like that. Now again, the important thing is we have not touched the SpeedBoostPowerup. The SpeedBoostPowerup is just calling it through the interface. And because this interface is applied with the same signature, we can call it from different actors and they can do their functionality in different ways, right? This looks very different than how the ball pawn is doing it. And that's fine. And that's one of the advantages of doing it this way. Compile, save, let's test it out. So this projectile should be moving slow, pass through here, and then move at a faster speed, and then wait, and then return. And then it's slow again. And just to show you, I have two different actors that are behaving differently, that are implementing their behavior in different ways through the interface. And this is really the entire point of using interfaces is I can now add infinite number of other things. As long as they apply the interface, the speed boostable, then we don't have to touch all the other stuff. We're only touching the actor we're working with, which is really good for working on a team and for making things modular.